Introducing Bizdata's eZintegrations, a cutting-edge integration tool designed to simplify the connectivity between diverse data sources and Oracle Vector Database, including text embeddings. By simplifying the integration process, eZintegrations minimizes technical complexities while delivering an efficient data experience. Join us in this video to see exactly how eZintegrations transforms data integration, making it faster, easier, and more efficient than ever before. To get started, log into your account and initiate the process by adding an integration bridge. The first step is to configure your data source. Selecting API as the data source, as we will be utilizing the sales order API from an e-commerce data. Enter the product name and business object associated with the API. Alternatively, you can select from the API catalog, which offers a comprehensive selection of APIs for various business needs. Next, input the endpoint URL for the API. If you have selected the API from the API catalog, the URL will be automatically populated for you. Enter the required authorization details to ensure secure access to the API. Next, proceed to test the API to verify the response from the source. This is the sales order data being retrieved from the source. Next, navigate to Operations to begin transforming, wrangling, and cleaning the data. We can see the list of all the operations by scrolling here. The data is received in JSON format under the key Bizdata dataset response. We'll extract the key and its values using the data extractor operation. Our response in the source is JSON data in a nested format. We need to convert the single-line JSON response to multiple lines tabular data as our target is Oracle database. Thus, we'll use the single-line to multi-line operation, passing the key name where all the source data is stored for processing. Now, using the raw sentence generator operation, we'll convert all the data into sentences for later use in embeddings. We'll leave the include keys parameter empty to include all keys received from the source. The key name neural field will be input in the row response key, where all the generated sentences will be stored. Next, we'll configure the Gina embedding API using the API operation. This API will embed all the previously generated sentence, that is, it will create vector representations of the input data. Entering the target name as Gina API and business object as Gina text embeddings. Enter the endpoint URL and the required authorization details to configure the API connection. Using the Python operation, we will store the vector embeddings into a new key called vecpayload. Next, using the append operation, we will add a unique key to the data and extract the vectors stored in the key vecpayload. To eliminate unnecessary data, the eliminate operation is used, ensuring that only relevant data is retained. Next, aggregation of all the values in one array is done using the data aggregation operation. Under Group by Key, we are grouping all the values available in the table using the collection ID, created in append operation. Under Array Key, any name relevant to the dataset can be passed. Lastly, a tuple is created for all the columns to read data from single line using single line to tuple operation. We are using this operation to load data in bulk in database, so we are mapping the columns along with the comma-separated values. Next step is to select target under data target. Before configuring data target, we will see how our table looks in target. This is Oracle database showcasing orders vector table with all the columns. The following step is to select the data target, which is Oracle database. To do so, we will be configuring the data target with database details, as can be seen in the video. The tuple key that holds the tuple data, from single line to tuple operation should be passed here. Finally, enter the query to insert the data into the database, ensuring it follows the specified format. The last step is to complete the process by furnishing the details in the summary section. Provide the name and description of the integration bridge. Under Schedule, scheduling the frequency of integration or to 60,000 seconds. Once everything is done, click on Submit. The integration bridge can be seen in the list. We can now proceed to run the integration bridge and check the results in live streaming logs, since the integration bridge is now built. Data can be seen coming to the target. It can be seen that sentences are formed under the column Neural Field. Under the Neural Field Vector column, the vector embeddings related to the neural field can be seen. This indicates that the data has been ingested successfully. With eZintegrations, get a seamless and faster integration experience.